Today we're going to talk about how to install a heat bed on the BigTreeTech Octopus. Now this is going to be very similar to the Octopus Pro, but I'm going to walk you through the steps on how it is done. So first thing that we need to know is where the actual power is located on the board. So in order to do that, what we're going to have to do is we're going to have to go over the web browser and actually look it up real quick. So I'm on the BigTreeTech GitHub page, and I'm going to go to repository, and then I'm going to type Octopus, and this will give us the actual information we're looking for. Now there's a manual down here, but also under hardware, you can go to the pinout diagram. Now I've already downloaded that by clicking over here. So it's actually this. So if you zoom in on this, you can see that for power, we're going to have to connect the heat bed power here and the power for the board over here. So I'm going to scroll out for a second, and let's take care of that first with the power supply. So on the desktop, what I'm going to do is I'm going to go over here and I'm going to find our actual control power points. So you can see that here's the board power, and then we have the power for the input side for this. So voltage is going to be red, ground is going to be black. So I'm going to connect first the voltage one here. Obviously the power supply is disconnected right now. And I'm using ferrule connectors. This makes it somewhat safe. Now there's normal ones that come with the board, but I don't have them on here at the moment. So that's the first part for the board power. Now we're going to have to do the ground and the voltage again. So right here you can see that it's ground. So we're going to tighten this down. Then we'll do the actual voltage on the next one, and then we'll double check this on the actual diagram to make sure we've done it correctly for the pinouts. So I'll tighten that down for the moment and close that. And then let's go back over to the actual desktop of the computer, and we'll scroll back in so we can see this. So let me scroll it over a little here. So we have our voltage, ground, voltage, ground. So let's double check that real quick. And that in fact is what we have. You see it's voltage, ground, voltage, ground. So next what we need to do is actually do the heat bed. Now the heat bed is going to involve two pieces. It's going to be obviously the connection that we have right here for over in here for the output power. But you can see that I've only peeled this back. I have to put a ferrule connector on to make it safe. So you can insert it like so, and then take a ferrule crimp and insert it into here, put a little pressure on it with the back of the wire where my fingers are, and then crimp down. And that'll give you a really nice connection right here to hold your actual connection. So let's go back over to the board power. And we know that this one is actually voltage. So we'll slide that in. And we'll tighten it down over here. And this is going to be for the output power, like I said. So I'll tighten this one down as well. Now it doesn't matter what polarity for the actual heat bed, because there's basically a resistor in here that generates heat. But we do need to tell the temperature. So we need to locate the thermistors on the board. So I'm going to close this for a second, and we're going to go over and look to see what those are. So over on the diagram, if we scroll over to the right, I'm going to probably have to scroll out so you can see this a little. You can see that it says TB, T0, T1, T2, T3. So over here, there's actual lettering for J44. So J44 is our heat bed right here. And then you can see that the thermistors are actually over here for the actual output power, but the thermistors to tell what temperature are over here. Now a thermistor is basically a piece of glass with wire running through it, and you can tell by the known rate that it passes through there with a pulse what actual temperature you have. So I'm not going to go into too much detail on that, but I'm going to show you how to connect it real quick. So let's go back over to the actual desk. I'm going to connect the actual thermistor, which is this red wire. It's actually located right in here. And I'm going to connect one connection here and the other one right over here. Now I had to fake out this connection because I wanted to do 24 volts on this. Next, what we need to do is we're actually going to set up the actual imaging here. So I'm going to grab an actual SD card reader for our SD card, place it in here, and place this in my computer. So you may hear a beep in a moment. Now let's go back over to the desktop. We're going to have to bring up VS Code. Inside VS Code, I've already downloaded the actual firmware right here, which is version 2.1.2.1. So it's already downloaded and extracted. So I'm going to go over here. I'm going to open the folder, go to my downloads folder, open Marlin 2.1, open Marlin 2.1 again, and then select the folder. Once this loads up, what we're going to have to do next is actually figure out what our board is. So I'm going to go to Marlin, Source, Core, Boards.h. I'm going to search on Octopus, and as you can see, it's the one right here. Now you can confirm your actual chipset type being right here, the STM32F446ZE on your actual motherboard. I'll show you that real quick. Over here, if you look at the writing on your MCU, you'll see that writing. That's what we're actually referring to. So let's go back over to the desktop of the computer. We're going to have to minimize core source, and then we're going to go to configuration.h. We're going to search on motherboard. We're going to highlight the ramps over here and paste ours over it. Next, what we're going to do is we're going to change the serial port to -1 so we can communicate with the board after we load the firmware. And then to set up the actual thermal settings, we're going to search on thermal, and that should bring us to thermal settings. Now, as you can see, there's a lot of different settings in here. Right now, what I'm going to use, just to show you the example, is the actual number 8. Now, you're going to have to look up your manufacturer if it's different, and it should be in this list. If not, then I guess you're not using it, at least for the moment. Now, there are other ones down here that are listed for different types of sensors. And then, of course, 0 is not used. And there's a couple other things that you can do to fake out a sensor. But what we need to find is the heat bed. So I'm going to find it right here. I'm going to remove the 0 and put 8. Now, there's a couple other things down here that are of importance, such as the actual minimum temperature. So I'm going to scroll down and see if I can find it. So you have your heat bed minimum of 5 degrees. And then your maximum is 150. I'm going to move this down to 100 just for safety, because I don't really ever go above 50 when I use it for Celsius. And then down here, there's going to be a couple other things like overshoot. You can just leave these the way they are. Probably up around 150 would be fine for the setting up here, but I'm just changing it to show you that it can be changed. So let's scroll down a little further. Now, there's ways to actually set a more precise temperature. I'm not going to actually talk about the PID settings, but there is something I want to show you down here. and that's thermal runaway protection. So the thermal runaway protection prevents actual damage by fire, meaning don't change it, leave it alone. So now that we've got that all set, we need to set up the build. So we're going to go over here. These are actual processors. So we're going to look for the STM32F4. We're going to search inside here for Octopus. Once we find Octopus, we're going to highlight it, copy it, and then we're going to minimize the INI folder. We're going to go to the INI for Platform IO, highlight the Mega 2560 environment, and paste ours over it. So now we're all set there. I'm going to do a clean, and then I'm going to do a build, which is the checkbox over here. And once this builds, if you see something like this where there's red, that means you've actually made some kind of error. So what we need to do is figure out what this is. So let's try doing the checkbox again, just in case it's just something that occurred. Now currently it looks like there is an error. So it has to do with the motherboard. You can see that it says configuration.h unknown motherboard set. So it's a good thing that we have the error. At least we can see what's going on. So I'm going to scroll up here. I'm going to search on motherboard. And it looks like I pasted over this. So I think it's board dot or underscore BTT underscore octopus underscore V1 underscore 1. But we can double check by going to source core boards.h. We can find ours, which is right here. And that's what it looks to be. I just apparently forgot to get the B in the actual name. So let's click the checkbox again. Now, red means that it's a compiler failure. Yellow means a warning. Warnings you can generally ignore. So you may see an actual yellow warning in here. It's no big deal. While that's building, we can watch it over here. It'll start to populate this folder with all the things it's building. And when it's finished linking them, you'll first have a firmware.elf file, and then you'll have a firmware.bin file. So there's the elf, there's the bin. So let's right click on this, and we're going to do reveal in File Explorer. Now here's the actual SD card that we're using. So we're going to right click, and we're going to send it to that drive. So as you can see now, it says firmware.bin. If this works correctly, it'll rename this file to this one, and the date from this file will be the one that we actually installed. So if you're successful, there'll be one file left on here. If you have trouble loading and you don't have firmware.cur in capital letters, create a blank file named firmware.cur without any other extension, and then it should be 0 kilobytes. That will take care of that issue usually. So now that we're done with that, we're going to have to go over to the desktop of the desk here. Pull out the drive, extract your SD card, and place it in here. So I'd advise double checking all your configurations to make sure you're connected correctly. Next, what we're going to have to do is connect our USB connection. Now I've left the jumper off at the moment. Whoop, actually it's back on. So you're going to hear a beep, but it's loading the firmware as we speak with USB power. So I'm going to disconnect this because normally we don't run with this anymore, so we'll take it off. And the board won't power at this point unless we plug it in with a power supply. So I'm going to have to grab a power supply right here and plug it in. So this is a good time to keep your hands away from the board because it's now energized. So let's go back over to the desktop in just a moment and see if we can actually connect to this. Okay, so what we're going to have to do is we're going to have to find the COM port. Now, right now it says COM port 4 when I opened it up for Pronterface. This probably will connect, but I want to show you something real quick here. So if we're on the desktop and we go to Device Manager, inside Device Manager, we can confirm what ports are in use. So this one is default being COM port 1, and then this one is the STM Microelectronics Virtual COM port number 4. So let's try and connect real quick. Looks like the printer is now online. So you can see that there's temperature right here. So let's try something here. I'm going to put my hand over the thermistor on the board, and hopefully the heat of my body might raise the temperature a little bit right here. So let's see if I can make this bigger. Apparently it's not working, so watch the actual red line right here for bed. And what we're testing is to see that the temperature actually rises. Now we can actually look right over here, and you can see there's a slight spike going up. So let's see if we can see that. Yeah, you can see that my temperature is raising it above ambient just a little bit. So what we're going to do now is actually try and test it with the actual power. And what will happen is you're going to hear the power supply increase just a little bit when I do this. So I'm going to set the bed to 50 degrees Celsius. Maybe I'll set it a little bit lower for now. Let's do 25, maybe 35, and then set it. So you'll see this spike, and you'll see it go up. So you see the spike right here, and in a moment you should hear the power supply is going up. You can feel that it's actually warmer now, and that's all you need to do to set up your actual heat bed on your configuration. So to turn it off, you can go like this, and the power will go down. Now I'm going to show you something that a lot of people see and they get freaked out about, and they don't understand what's occurring. So I'm going to pull the thermistor connection right here so it can't tell temperature. And watch what happens up in here. We may get a message right away, but we may not. So let's try and turn the power for this back on and see if it actually works. It should not. So you see what's happening right here, where we tried to enable it and it said error, minimum temp, error, halt, kill, called. Basically it's stopping the printer because you're in an unsafe condition, meaning that you don't have a thermistor connected to tell temperature. So I hope this is helpful to everyone that's been trying to do this. At this moment, I want to thank my patrons and people on PayPal for their support. And I'll play a little list of those people at the very end of the video. Everyone take care, be safe, and I'll talk to you later.